Hello students. So today we are going to discuss the next chapter, that is momentum, impulse and collisions, right? So let's start. Collisions. Basically we are going to discuss about collisions, and before that we will discuss about, in the collision itself, the important concept that comes is about the impulse and impulse momentum theorem. Impulse momentum theorem. That's a very important theorem. Let us discuss first we'll discuss about what is impulse and also impulsive force. Impulse and impulsive force. Okay, so suppose there is a body. Let us say, understand this with an example. Suppose this is a body, okay, and this body is going with a velocity. Some velocity it is going with, you can say that this is going with velocity v1 or u1, you can take initial velocity. And there is another body. Let's take, there is another body. This body is going with velocity, let us say, I am just drawing velocity as a vector, okay. So signs you can understand, they may not be in the same direction. This is u2, right? So they are going and they are going to collide. Let us say they collide. So what happens? Let's say this is the first body, and similarly this is the second body. They collide. Okay, this is what collision is going to happen. So when they are in contact with each other and they are going to apply force, this is the first body, this is the second body. So first body will apply some force on the second body like this, okay. This we can say force on the second body, F2, and first body will also get some force due to the second body. It gets this force, that is F1, you can say. You may write F1 due to 2 and F1 due to 1, okay. These two forces are like action and reaction forces. So this happens when the bodies are in contact, and just after collision, what will happen? They will separate. So let me draw the diagram here again. They are going to separate after collision. So just try to understand this, what's happening. So this is the velocity of the body after collision, let us say v1, and this is v2. Okay, that v1 v2 may have plus minus sign, okay. And what you need to know here is, we need to focus here during collision. This is the first middle diagram. During collision you need to focus, okay. You need to focus during collision. Before collision they are not in contact. After collision they are also not in contact. During collision they are in contact. So because of that there is a force acting, and immediately they will separate. So this force, which you can say F12 or F21, which is acting on each bodies, these forces are acting for a very small time, okay, very small time. So what is called impulsive force? The force that acts on a body for a very small time, very small time. This force is called impulsive force. Understand? This force is called, so here F12 F21, which is acting on each body during collision, that is an impulsive force. That's an impulsive force. So whenever two bodies collide and immediately they separate, right? The force that is acting is called impulsive force. Okay. Now, what is impulse? What is impulse? What is impulse? Impulse is defined as, we can give some symbol for impulse if you want. You can give the symbol for impulse as, let us say, J. J is impulse, and you may write this as linear because we are talking about linear impulse, and obviously it's a vector quantity. Here I am not putting as a vector because it's a one dimension. In 2-3 dimension we can put it as a vector, right? So this what it is, impulse. Okay, this is the symbol for this impulse. So this linear impulse or impulse here, that is defined as the impulsive force into the time duration. It is impulse defined as the product of. See, this is the definition. Okay, that's the concept only. It is the product of impulsive force and time duration for which the impulsive force acts. What is impulse? Impulse is the product of impulsive force. So two things, product means two things it is. One is impulsive force and another is the time duration. So if I write what is this linear impulse, here I can write the formula for that. The linear impulse will be the impulsive force which is acting into the time. Let's say time is delta t. This formula we can use when the force is constant. Okay, this formula we can use when this force, this is an impulsive force, this is constant. We can use this formula for impulse. Okay, this is the formula for impulse. Now, what happens if the force is variable? It is varying over the time, right? It's a function of time. Then we should write the linear impulse as integration of f dt, going from the time t1 to t2. Suppose the force is acting between the time t1 and t2, so we must know that that interval is of course t2 minus t1 or delta t, but force is a variable force. So the force is variable. We cannot just multiply force into time interval. We need to integrate. Okay, this is the concept. Now there is no other stories. Okay, don't expect stories. You need to understand, those who are focusing for competitive exam, your mindset should be something else. You don't just think that you should go get this much theory, that much theory. This is the theory. This is the concept. If you are paying attention to this concept, it's a mathematical concept. You need to understand what it is. Now the same thing can be written in so many statements, so many words. That's what is books which you have to read. Understood? So this is the concept which we can use in problem solving. So this is the definition of linear impulse. Now let us understand here linear impulse theorem. Again we'll come to collision. This is impulse we have discussed, impulsive force we have discussed. Now what is impulse momentum theorem? Let's understand that. Impulse momentum theorem. Impulse momentum very important principle, very important principle, impulse momentum theorem. So let us say that there is a body, on this body there is a impulsive force act or any force act. Impulsive force means it is acting for a small time, that's all. That's what is impulsive force. And if it is not acting for a small time, then it is not an impulsive force, it's just a force, that's all we did. So So we have to, understand the things by questioning. If you don't have the ability to question, you cannot, improve. You cannot improve in your life. You want to grow in your life. That's my personal suggestion, that if you want to grow, you must have the ability to question. You must have the ability to dissociate. That means to have a different thinking. It's not that all of us have to, just accept things which is being told and just nod our heads. In that way, animals are better in that case. They will just nod their heads, or if they don't, you can beat them. But we human beings have got the capacity, the capabilities to think and reason, and in a different way we can, do. We can all be different, and that's what it is. That's the beauty. Right, so impulse momentum theorem, you have to understand this force is acting. This is an impulsive force. It may not be an impulsive force as well. Okay, but you need to understand this. So let's understand that it's this force has acted for some time. This is the force which is acting, and it may not be constant also. It may change. And let's say it has acted for a time interval. Let's say here time was t1 when the force started. Force starts to act. Time is t1 here. And here force stops to act. Now force is not acting. The time is t2. Okay. This f is not the same f. It may be constant, it may be variable, but this is the force which we are considering, right? So first of all, let's write what is impulse. I am writing J as the linear impulse. So what it is, and in general I can write F force, integration of force into dt. If force is variable, you keep inside the integration. Force is constant, take out of integration, right? That's what in general. Now, what is impulse? And let's say its velocity has changed. Initially, it was moving with a velocity of, let's say, u, and now it is moving with a velocity v. So, what is impulse? No, this is linear impulse. This is change in momentum, let us say. Delta p is change in momentum. What is change in momentum? Delta p. Change in momentum, let's say its mass is m, body has a mass of m. Of course, mass is not changing. Assume that. So, change in momentum is mv minus mu, or you can say mv minus u, right? This is change in momentum. Now, remember Newton's second law. What is Newton's second law? Newton's second law, let me remind you, Newton's second law, which is defined as force, that is the of course net force, is rate of change of momentum dp by dt, right? dp by dt. So when you bring this left side, this is dp, and you can integrate. Now you see right side is nothing but delta p, and left side is nothing but active p. So if you see here left side, this is nothing but integration of f dt, which is nothing but what? That is linear impulse, isn't it? That is the linear impulse. And this is the change in momentum. This theorem is known as what it is? It is known as impulse momentum theorem. Impulse momentum theorem is known as impulse momentum theorem. Okay, that's impulse momentum theorem, right? Understood? I hope you have understood. Okay, then let's move next. Now let us understand again the same thing, what is meant by collision. Collision, what happens during collision. So now we are focusing in collision. So this is one body and this is another body. Okay, let me just keep some better diagram. My diagrams are not coming good. Okay, I think this is looks nice. So this is an object, this is another object, and it's not identical. You can consider this little bit larger, and this is the situation before collision, and we are considering head-on collision. That means the center line joining the center, this is the line joining the centers. Okay, and collision is happening along the line joining the centers like this. So this is the first body and this is second body. This body, this velocity of this body, let's say this mass is m1, this mass is m2, its velocity initially is u1. This velocity means this velocity of the center. Okay, this velocity of the center is u2. Now this is before collision, right? What happens during collision? Again same thing which I told. Let's consider during collision. During collision, these bodies exactly come in contact at a particular point, right? So this is the point where they are contacting. So they apply force on each other like this. So the force which is directed towards right side is acting towards the right side body. Okay, so this force which I am drawing here, this is the force F2 and this is the force F1. You may say F1 F11 due to 2, F12 due to 1. You may say like that also if you want. Okay, you may write this as F of 2 due to 1 and this is F11 due to 2. Okay, and this is the collision happening at this. After that what happens? After that they will again separate. So they will separate out. Let us say that they separate and they start moving away from each other, right? So now this is going to move in this direction. Direction may be different, but I'm just writing this as vectors. So this is v1 vector, this is v2 vector. After, so this is before collision, during collision, and this is after collision. Now what is happening here is we want to understand what is happening during collision. Okay, so during collision what is happening, let me just explain this with the help of force. This force which is acting, you can say either F12 or F21, this is the force, and you can just look at the first body. Left side is the first body, right side is the second body. So on the first body, as they are going to hit each other, they will compress, and this force, generally this force increases like this, and then this force reaches a maximum and then this force decreases. This is a variable force we are taking, and it is acting for a time duration, right? You can see this time delta t is the time interval. After that this force is not acting, so the body separates, the contact is over. The contact is only for delta t time period, right, during which the force is varying. So you can see here there is a symmetric graph, and this is of course half of the total time, right, where it reaches the maximum. So during the rise, the force increases during the first half and the force decreases during the second half. So during the first half, that is called deformation. Okay, you should note that during the first half, or you can say this side is called deformation. Deformation. And the other side, this is called reformation. 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 So during the first half, they are compressing against each other, and the body is getting deformed at the contact point, right? And it gets deformed maximum up to this point, delta T by 2, right? After that, the force decreases and the body starts reforming its original shape, and then they separate gradually, and after delta T, they completely separate. Okay, that's what it is. Forces acting. Deformation, deformation, both are equal and opposite. And if the body is, let us say there is no loss of energy happening, then reformation, deformation diagram will be completely, symmetrical. It is always symmetrical, but during deformation or during reformation, the changes of energy is not going to be same. So if there is permanent deformation happens, then what happens during such collision is that there will be some loss of energies can happen, right? The shape of the bodies can change. So if deformation, reformation are equal, then the body will be able to regain its original shape, right? Okay, coming back to here, now let us just study the change of momentum of the first body. So if you consider Newton's third law, Newton's third law. So force acting on 1 due to 2 is opposite of force acting on 2 due to 1, because this is action and reaction forces. So total force on the system, net force on the system is F12 plus F21. It is going to be 0. And because net force, net momentum is 0, you can write it as delta P by delta T. Delta P means here system momentum. So what will happen? You can see there is no change in the system momentum. System momentum is 0. That means the momentum of the system before and momentum of the system momentum before is equal to system momentum after. We can say that, right? So if we say that initial momentum, then m1 u1 plus m2 u2 can be written as m1 v1 plus m2 v2. This is what is. So this we can write. Okay, this we can write. Let's say that this is equation number 1. Okay, and now also note that if I want to write impulse, this is one way to understand this. Second way is to understand through impulse. So what is the impulse on first body? Impulse that has happened is J1. J1 is the impulse on first body, which we write as F12 into delta T. Assuming it is constant. If it is not constant, as you know, you can integrate. Then it will be dt, right? dt. Then similarly, J2 is the impulse on second body. It is F21 again into dt you can take, because it's a variable. Now this is change of momentum of the first, and this is change of momentum of the second. So if you take total change here also, this is another way we are understanding change of momentum of the system. System is change of delta P1 plus delta P2, or you can say the impulse 1, impulse 2. When you add here, this is going to be again 0, because it will come F12 plus F21 into dt, which is again 0. So again this concept, impulse and momentum will give the same thing. The total momentum will remain constant. So m1 u1 plus m2 u2 is m1 v1 plus m2 v2. It is giving the same first equation, right? So this way we can understand. Okay, next what happens in collision, that is what we are going to study in second law. let's understand second law. Not second law, basically it is a Newton's law, that is Newton's law of collision, you can say. So Newton's law of collision defines, this is based on Newton's law of collision. Newton's law of collision. Newton's law of collision. So Newton's law of collision gives us how collision is happening. So just before and just after, you can see, suppose this body just before, this is u1, u2, their velocities, and just after this is going with v1, v2. Okay, so we define a term called coefficient of restitution. Coefficient of restitution. Coefficient of restitution is E, and E is defined as relative velocity of separation of two with respect to 1 divided by relative velocity of approach of first body or 1 with respect to second. Okay, this is the definition of coefficient of restitution, and it indicates about whether the body is able to restore its shape or not. If the coefficient of restitution is high, the body is able to restore its original shape. If the coefficient of restitution is less, the body is not able to restore, it is getting permanently deformed and there will be loss of energies. Okay. If the value of E is 0, actually 0 means it is not able to regain its shape. Okay, 0 means completely it is lost. Okay, 0 means it is completely lost, or maximum loss, you can see it's happening. And if it is equal to 1, that means it is completely able to regain its shape, because it's like the ratio of just after and just before. So if after and before are same, everything is same, the structures and shape is same, then E will become 1, right? That's the concept. Okay, so now if you define this E, I can say that E is nothing but V21 by U12. That's the relative velocity, and from here you get this is V2 minus V1 by U1 minus U2. Now if you can write this V2 minus V1 as E times U1 minus U2, and you can make this equation as equation number 2. This is equation number 2. Now this equation 2 and first, which was momentum conservation, m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. These two equations can be solved, and once you so on solving these two equations, first equation which is based on momentum conservation, m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Second equation is based on E, coefficient of restitution, which is v2 minus v1 by u1 minus u2. Now solving those two equations, you will get velocity v1 and you will get velocity v2. So after collision, what is the velocity? So I'll tell you how to remember this. So you can write like this: v1 is made up of some coefficient into u1, some coefficient into u2. v2 is made up of some coefficient of u2 plus some coefficient of u1. You have to write like this, and then in the denominator everywhere you should write m1 plus m2. The denominator is made up of m1 plus m2 everywhere. Okay, all this denominator is made up of m1 plus m2, m1 plus, that means that's the total mass. Then how to write the numerator? Let's understand this. So in the numerator here you will write as m1 minus E times m2, and here you will write 1 plus E times E times M2. Here you need to note that this M2 and U2 in the second term will go together. Okay. Now here the first term you will write M2 minus E times M1. You will interchange M1 M2. 1 plus E times this will become M1. So in the second term particularly there is a chance to forget. So M1 in the second term will always be there with U1, and M2 in the second term will always be there with U2. Okay, this is the equation which you need to remember. Once you know this equation, then you can work out questions on them, right? So I hope you have understood the basic concept, and in the next session we can cover the type of collisions and some other type of cases, right? Thank you for your attention.